So, good morning, guys. And hello, am I audible? Okay. Today, our topic is rest of the part of transformer. Uh, Now, we'll discuss today about the construction of the transformer. Generally, look, in electrical branch, you have to deal with the phase. First is that is the single phase, which are the used in your domestic purpose, and second one is the three phase. I think you all aware of this name, that is the single phase and the three phase. Three phase are generally used in the industry. So we are basically, for the basic, we are dealing with the single phase. And in your hard study, you will get the three phase also, higher semester. So first, construction of the transformer. Guys, yesterday you have seen this type of things in the transformer. Today you can see this type of construction. And now you already know that transformer have a two part, generally two part. That is, first one is the magnetic core. This one is the magnetic core, and this is the coil. Okay, so we can divide it. We can divide it into the two parts. That is magnetic core and another part is winding or the coil. So in this picture you can see this is the magnetic core, or simply it is called the core. This is the core portion, okay, and this portion is the winding, okay, and this core and this winding are insulated, okay, this is not connected electrically. So if we go for these things, then first magnetic core, okay, so this portion and this portion are called limbs, okay, and this is also called limbs, and this portion is called yoke, okay. And what is the purpose of this magnetic core? The purpose of the magnetic core is to provide a magnetic path, provide a magnetic circuit, okay. This is the purpose of this magnetic core. The purpose of the magnetic core is that provide, just write down this, because this is also the note also, okay. Provide path for magnetic flux, okay. So maximum amount of, if you put some coil over there, then a flux is generated. A flux is generated this type. This maximum number of flux is follow this path, and very less amount of this path flux will follow this air path. Okay, so this is the highly permeable materials so that maximum number of flux will follow this path and it will complete the circuit, and few number of flux are going through the air. Okay, and so this is not our working purpose, this is only the working purpose. So this is the loss. So maximum path, maximum flux, maximum flux passes through the path. Okay, so whenever there is a some action is there, so some portion are going to the other side, and there is, this is also a loss. So we have to provide highly highly permeable material. So which type of material are these? This is high grade silicon steel. Just remember this magnetic path or magnetic core is made of high grade silicon steel. Okay, high grade silicon steel is used. Now there is some losses is there. Some losses is there. Why these losses are occurred? There is a two type of loss occurred by this core. This is, one is hysteresis loss and another is eddy current loss. So hysteresis loss and eddy current loss. So which are the hysteresis loss and eddy current loss? First, this is the magnet. This is the magnet. Okay, whenever a flux is induced in anything, this is a flux. So it became a magnet. So this is the north pole, this is the south pole. But you can see this is the AC current we are applying. We are applying AC current. So AC current means it is a sinusoidal. So here the amplitude is means amount of the flux is very less. Then this is the maximum. Again it is a medium. Then it is zero. Again negative terminal. It is opposite direction means flux is generate. Flux is generate in this way. Flux is generate in this way. So this north pole became the south pole and south pole became the north pole. It is behave like that. So in this way it is occurring. So what happens? So if this is a bar magnet, if you consider a bar magnet, then how it is became a magnet? Because each element each element became a magnet. That's why it is became that's why it is became a magnet. So this is in, this is in, this is in, and just like uh, this is is sorry, this is in is. So ultimately this side is became the s, so it is s and this is n. So whenever it, and now it is change each half cycle, means whenever the flux is in this direction, then it is n. Whenever flux is in this direction, then this part became the n. So what happens? This will be changed in this portion. Look, in this portion, uh, I am showing that, and This is in, this is S. So you can see each elements here, each elements became in, and this is S. This is S, this is S. So this is became S. But each half cycle, this side became N, and another half cycle, this side became the S. So same material, one time it is became N and next time became S. First half cycle, this is N, and second half cycle, this is became S. So this is NS, NS, it is occurring. But what happens? All these elements are not convert at that time. Some of this element still remaining unchanged because n, this is n, but sometimes this is also became s because previous action is occurred. So all this material was not converted in the polar. Okay, the same polarity. So that's why this became some losses. So if you watch this, means wherever it is going to the in this path, it should be returned in the same path, but it is not returning. It is returning in the lagging because it required some time. So this is called the hysteresis. Hysteresis means something lagging. So wherever again you put some polarity, then it is going in this path but returning in this part. It will not return in this part. It is going in this part but it was lagging. So this is called hysteresis. Okay, so this is the loss of the hysteresis. So what is the another loss is this is the hysteresis loss. So why how could I remove this loss? Look, that's why core are laminated with a very thin material, thin lamination to reduce these losses. Okay, to reduce these losses, we are using the lamination of this core. Means there is a 5 to 0.5 to 7 millimeter lamination, and then we attached it. Okay, this lamination is made up 0.5 to 0.7 millimeter of the thickness. So if we attach this one by one, then it will reduce the hysteresis loss. So if anyone asks how to reduce the hysteresis loss, then you have to say, then just reduce this lamination. We have reduce the hysteresis loss. We have to use some of the laminations. So core material in first time it was made of pure iron, and it is a total in a block material. But after then, whenever it is found that the hysteresis loss is occurred, then we have to make some lamination and make a stack. Okay, a stack. Then it is became a highly permeable and less hysteresis losses material. Okay, so next one is the eddy current loss. Eddy current loss. Eddy current means a circulating current. Eddy current means circulating circulating current. So eddy current means a circulating current means where the eddy current is occurred, it is circulating in the same area. It is not transferred. Okay, so this is the losses. But where it is from where it is produced? It is produced by this core, by at this core by the flow of current. So it is a loss because this current we can't utilize. So which things is not utilized but drawing from our input material or input sources, then it will be the losses. So this is called the eddy current loss. Eddy current losses occurs at the core material. So say here is the thing that in this portion a eddy current is occurred. Eddy current is circulating over here. So what happens? We have to reduce this eddy current. So we make this lamination. We make this lamination with a varnishing material, means insulating, hitting, varnishing. So each other they are attached, but these are not connected electrically. So eddy current occurs in a small portion and it is tagged over there. That's why we are using the lamination and with the varnishing. Okay, means insulating material lamination. Then it will reduce this eddy current. Okay. Next, we are talking about the winding or the coil. You can see there is a two things are there. One is winding and another is core. So this is uh, more or less about this core. And now we are talking about the winding. So winding are generally carrying the current. Okay, in this coil, the current are flowing through the winding. So this is a made of, generally we are using the copper. Okay, so that it will carry the current and it will provide the less resistance. So it should provide less resistance. Okay, now which type of losses is occurred? You have studied there is a heat. Heat means I square R and I square R T for the time. So here the losses is occurred due to the I square R loss. This is called copper loss. So heat is generated over there. That's why a copper loss is occurred. So how could I remove this? Then if the transformer is more than 1 kV, then we are using the oil. You have seen so many transformers uh, in your domestic purpose use, but small transformer are not required this type of oil. But big transformer we are using the transformer oil so that it can dissipate the heat. And in the small transformer there is the air is sufficient to reduce the heat. So this is all about the construction of the transformer. And now this coil and this core are totally insulated because it is set in a PVC bobbin. Then it will winding up. So it is used in the insulating material. Okay. Next is type of transformer. Okay, have you any question regarding this? Okay, someone asked a fast internal. So fast internal, it will syllabus will be up to the your completed portion. Just try to learn this thing, not try to just read or cover this thing. Whatever you are watching, maybe you are not in the electrical department, but this is the knowledge. Anytime you can apply this, or anytime it may be required. So there is a two type of transformer. You can see this picture. Okay, so transformer are generally two types in construction for the single phase. First one is called the core type transformer and second one is called the cell type transformer. So you can see this is the core type transformer. in this core type transformer there is the core and the windings are in the two lanes. This is called the core type transformer. Okay, and another is the cell type transformer. Cell type transformer is looks like, okay, so if this is a primary and this is the secondary winding, okay, and in this case core, this is the primary and this is the secondary. Okay, so in a same core, this is the windings is there. This is a very small type transformer are doing in this pattern, and this is the core type transformer. Okay, this is the general two part, and now we are going for the mathematical expression of the EMF. Now the EMF equation. Sorry. We know that we are applying the AC. So this is the AC signal. So whenever this is a AC and we also, this is a also AC. So this is input, this is output, this is a load. You can say this is a load. Load means it may be a bulb, anything. Okay, so this is called primary. This is called secondary. Okay, you can see, the AC is always not same. So sometimes this is zero, sometimes the value of this flux input value is current is here, then this is the maximum, then again minimum, again negative direction in this way. So the flux generated due to the current of the AC is not uniform. So flux is, we can say flux is the F max into the sine omega t. Okay, the generated flux is this. And now, as per the Faraday's law of electromagnetic induction, EMF generated is given by EMF is generated, or you may say E is generated is given by N. N is the number of turns. Number of turns in the primary and same in the secondary. For primary, this is N1. For secondary, this is the N2. Okay. So number of turns into d phi dt. Okay. This is the first equation. Only this is the magnitude. This is only the magnitudes. Okay. 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 This is the equation, but it has some the direction. So what is the direction? Direction is given by the Lenz law. Lenz's law. This is given by the Faraday's law of electromagnetic induction, and this is a Lenz law. Lenz law saying that it is opposing the source, means from which it is generated, it is opposing the source. This is the direction is the opposite. So EMF is given by just given with one minus sign. So it is the generalized equation is d phi dt. Okay. Now this EMF is generated over here, which are providing over here. This is E1 and EMF at this end, the secondary, that is the E2. So for we are dealing with the first EMF E1. So E1 is given by minus of because minus is for the Lenz law, it is the direction. N1 is the number of direction, number of turns at the primary. N2 is the number of turns at the secondary. Okay, so d phi, phi is the fixed, phi is same. Okay, d phi dt, and we can write the value of the phi over there. Phi is minus of n1 d dt, and phi is phi maximum into sine omega t. Okay, here we also can write, look, if a derivative gives the derivative, then what we get, that is minus n1, this phi is constant, so phi max, and sine omega t means that is a cos omega t.
Omega t into omega.
Yes, yes, cos omega t, and that is omega, because t is here, so not use t. Okay, t omega t and omega. Sine omega t is given cos omega t, and this omega t for this omega. Okay, up to this we get this. Okay, then we can write this minus into here. So n1 phi max omega into minus cos omega t. Okay, up to this I think it is clear. So then we can use this. It is, we can use cos omega t equal to, we can see sine, or you, this is for the general equation. I am writing for the general equation. So this is the cos theta, cos minus cos theta, we can write sine theta minus 90 degree. Okay, so here we can write same way, we can write same thing, that is I am writing the another point n1, and we can write sine omega t minus 90 degree. Okay, up to that it is clear. Okay, so in this portion we can write some e. Look, e is given over there, em, because it is taking with the maximum flux, it is dealing with the maximum flux, so we can write that that is the em. Okay, and we also, the omega is also means 2 pi f, omega is 2 pi f, so we can, this is, we can write n1 phi m 2 pi f sine omega t 90. Okay,
यहाँ
and
पर ओमेगा एंड
omega, this omega, this omega, this omega,
Yes, sir.
it is just written just like this. Okay,
सर
now
ओमेगा एंगुलर वेलोसिटी है क्या सर?
yes, yes, angular velocity is omega, and it is given by this 2 pi f. Okay, this is the 50 hertz frequency. Okay, is that clear?
Yes, sir.
Okay, then
Yes, sir.
we complete this. I just write this omega equal to 2 pi f. Okay, for your convenience. Look, we make this thing, this is em. Okay, so we can write em, and this is 1 for the primary. Okay, just remember this notation. Okay, sine, we can write that is omega, and we are taking minus 90 degree equal to a psi symbol just for the minus 90 degree. Okay, so psi means minus 90 degree, means this is a plus psi.
Yeah, plus I.
Okay, so this is the equation, and em means, if em1 means, just write this portion, just write this portion, that is n1 means that is the number of turns. One means one indicating
primary.
primary. Yes, very good.
In primary.
Primary.
In primary.
Primary. Thank you. F max means flux at the maximum. Whenever sinusoidal, this is the maximum. Okay, so flux at the maximum and 2 pi f. Okay, so we can write in this way. And now we are dealing with the RMS value. I think you all aware of this RMS value. And in the first portion, what Mr. Anil Kumar sir will told you the details of the RMS, root mean square. Okay, so we are dealing with the RMS value. Whatever we are getting from the electricity supply, this is the RMS value. Okay, so RMS value of the EMF is the
It should be omega t plus sin.
what
EM1 sin omega t plus sin.
omega t. Yes,
Sir,
yes.
T छूट गया.
T should get. Thank you. Omega t it should get. Okay, thank you. And this RMS means this is the maximum value under root. So maximum value then root 2. Okay, this is the RMS value. So if we put over there, then what we will get, or this equation, I am writing this again so that this is E1, okay, or EMF at the 1. Okay, so this is again I am writing N1 phi m, omega means 2 pi f. Okay, then sin ये पहले छूट गया था, अभी आ गया. Okay, so under root 2. Okay, so this is the RMS value. This is the EMF RMS value. Okay, so this is, if we doing this, you can know this is 2 pi and this 2 pi and root 2. If you divided it, you get that is 4.44. Okay, just 1 minute. Someone is calling. So this is 4.44. So this equation may be 4.44. Okay, and this N1 phi m sin omega t plus psi. Okay, and so we get, ultimately we get this 4 point, okay, this phi max sin omega t, it is there, and n1 is the number of turns. Okay, in this way we can write down this equation. This is for the primary, and if we go for the secondary, just change this, n1 is n2, that is 4.44 phi m sin omega t
Into
okay.
Sir, F should be.
F is same. Frequency is there. Yes, F is frequency is there. Okay. So this is the EMF equation. You have to, don't write to memorize this. Step by step, just try to evaluate. Okay, then you can remember. Otherwise, after then you get the lots of equations. So many equation is there. So how could I remember this? One by one, step by step, then you can remember. If you cross check, maybe one psi, one f, it will be not remembered, but you can remember it. So then your equation may be built up. Just try to build up the equation step by step. Okay, just one by step. This is coming 5 maximum. This is the way of remember, but because in your books lots of equation, in your syllabus lots of equation, so just try to remember the basic. Okay, then you can build up it. And look, this is the there is a difference of E1 and E2, this phi and the E1 and E2, this is the 90-degree difference. Phi means there is a minus 90 degree. This 90 degree means lagging. Okay, this is called the lagging. So if you draw the phasor diagram, this is called the phasor diagram, and this is the E1, and same just like the E2, this is the 90-degree difference. Phase, this is the phase, and phase difference is the 90 degree. So this is the 90-degree phasor difference. So guys, have you any questions regarding this? Okay, guys, have you any question regarding this? The time is very less, only 2 minutes.
सर 3 मिनट है सर, 3 मिनट में समराइज हो जाएगा.
Summarize. Okay.
सर हिस्टेरिस लॉस एक बार बता दीजिए ना.
Yes, yes. अच्छा, हम
हिस्टेरिस लॉस.
yes, yes. हम नया बोर्ड ले रहे हैं. हिस्टेरिसिस लॉस क्या है? देखो बेसिक से एक बार देखो, ठीक है. ये है तुम्हारा मैग्नेट, ठीक है. जब इसमें हम लोग कॉइल दे रहे हैं तब इसका अंदर फ्लक्स जनरेट हो रहा है. जैसे फ्लक्स दे रहे हैं, ये फ्लक्स जैसे हम लोग अप्लाई कर रहे हैं, इसका अंदर जो मॉलिक्यूल मैग्नेट है वो भी इस हिसाब से अरेंज हो जाता है, ठीक है. इसका एरोहेड मतलब एन, टेल हेड मतलब इसका एस. सो इधर देखो एन एन एन, और इधर देखो दिस इज एस एस एंड एस. सो ऐसे करके पूरा अरेंज हो जाता है. तब ये पूरा मैग्नेट इस साइड में एन 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 करके इधर एन पोल एंड इधर एस 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 करके इधर एस पोल क्रिएट हो जाता है, ठीक है. ये है तुम्हारा फर्स्ट हाफ साइकिल में, से फर्स्ट हाफ साइकिल में एज पर द विंडिंग. एंड सेकेंड हाफ साइकिल में जब हम लोग दूसरा अरेंजमेंट, दूसरा हाफ साइकिल में पावर जा रहा है मतलब नेगेटिव ऑपोजिट डायरेक्शन में, तब क्या होता है, ये फ्लक्स का डायरेक्शन है दूसरा. तब हर मॉलिक्यूल को फिर अरेंज होना पड़ रहा है, हर मॉलिक्यूल को फिर अरेंज होना पड़ रहा है. इधर हो जाएगा आपका एस 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 एस, इधर आपका हो जाएगा दिस इज एन, दिस इज एन, दिस इज एन, हियर इज आल्सो समथिंग इज एन, समथिंग इन एन. सो अल्टीमेटली इधर हो गया एस, अल्टीमेटली इधर हो गया एन. लेकिन ये तो हो गया थियोरेटिकली, बट इन प्रैक्टिकल all material could not be changed at a time as per this time. It required some time. So as a practical क्या होता है, इधर n है, इधर n है, लेकिन बीच में क्या होता है, कोई अभी पूरा घूमे नहीं, कोई इस टाइप का है, कुछ इस टाइप का है, कुछ इस टाइप का है. सो इधर n है, इधर n है, लेकिन इधर n हो गया, इधर n हो गया, एस एस. सो इधर एस एन तो हो रहा है, लेकिन 100% कभी नहीं चेंज हो रहा है. से जब पहला बार आया तो 100% नॉट पोल हुआ, लेकिन जब ये हो गया सेकंड टाइम जब आया तब 100% नहीं से 98% ये चेंज हुआ है. बाकी 2% क्या है, अभी भी अनचेंज रहा. फिर इसको जब अगेन इसको फर्स्ट हाफ साइकिल, अगेन इसको फर्स्ट हाफ साइकिल दिया है, सॉरी अगेन इसको पॉजिटिव हाफ साइकिल दिया गया है, तब फिर इसको चेंज होना है एन में. फिर इसको सेकेंड हाफ साइकिल अगेन नेगेटिव हाफ साइकिल दे रहा है, तब इसको इसमें चेंज होना है. तो ऑल टाइम यू कैन सी देयर इज सम परसेंटेज ऑफ magnetic material are not converted into the magnet, properly magnet. So some losses is there. So how could we express this? So whenever this is from the say negative side, this is going to the 0, this is this portion, and again it is going to the positive side and it is going to the